Hello, welcome to today's lesson on multiplication of matrices. Matrices are strange things to multiply. It's not obvious, put it that way, how you can multiply two matrices together. And in fact, something has to be true in order for you to be able to be allowed to multiply two matrices together. We looked at the dimensions of a matrix last day. Remember that if you have a matrix like, suppose it's, let me get my pen on the go here. If you have a matrix that's, say, 3 by 4, what's it that its dimensions? Remember, the 3 stands for the number of rows, and 4 stands for the number of columns. All right? And that's columns. All right? Well, you can multiply two matrices together if, when you put them side by side like this, the first one has dimensions A times B, and the second one has dimensions B times C, if the numbers in the middle, those two numbers, are exactly the same. Now, of course, what that means is the number of columns in the first matrix must equal the number of rows in the second matrix. Now, it's kind of a mouthful, but that tells you if they can be multiplied or not. If that's not true, you cannot even multiply them. And now, once you know that the numbers in the middle are the same, if that is true, then how big is your answer going to be? How big is your resultant matrix? Well, that would be given by the two numbers that are on the outside. In other words, the number of rows of the first matrix and the number of columns of the second matrix. So in general, look at this rule right here. If your first matrix has dimensions A times B, right there, and if the second matrix has dimensions B times C, look to see if the numbers in the center are the same. Well, here they are. And then the size of your product matrix, or your answer, is another matrix with dimensions A by C, A times C, so A from there and C from there. All right? Now, that's what you have to do. That's what must be true in order for the matrices to be multiplied. But exactly how do you multiply them? Because that's really not even obvious. Come down and look at example number 1 here, for instance. Let's have a look at that one very carefully. Right there. Now this is on page 6 in your notes. I have a matrix A, and it has, let me see, 3 rows and 2 columns. So this is a 3 by 2 matrix. All right, that's its dimensions. Matrix B has, let me see, 2 rows and 4 columns. So that's 2 by 4. Am I allowed to multiply these? Well, you look to see if the numbers in the middle are the same. 2 and 2. Okay, they're both the same. That means that we are allowed to multiply them. And now that you know that you're allowed to multiply them, how big is your answer going to be? Well, that is given by these numbers on the outside. You're actually going to have a 3 by 4 matrix for your answer. So if you wanted to, you could even write down right now like a blank matrix that has 3 rows. 1, 2, 3 rows and 4 columns. So there you go. 1, 2, 3, 4. 1, 2, 3, 4. Now look carefully at that matrix. It definitely has 3 rows and it definitely has 4 columns. All right. So that's how big your answer is going to be. Notice it's not even the same size as the two matrices that you're multiplying. Kind of weird, but that's the way it works. Now, here's how you multiply two matrices together. In the first matrix, you always multiply rows, only rows. So 2 and 1 is a row, negative 3 and 0 is a row, 1 and 2 is a row. So you have row 1, you have row 2, and you have row 3. That's what your 3 rows are. In the second matrix, you always multiply columns. So there's column 1, column 2, C1, C2. Here's column 3, and here is column number 4. All right, so you have 3 rows in the first matrix, you have 4 columns in the second. So you always multiply rows in the first matrix by columns in the second matrix. Kind of strange, but that's the way it works. So let me give you an example of how exactly we do this multiplication. If you look at the element that goes right there, what if you wanted to calculate this number? Now I like to call this the number that goes in row 1, column 1, because that's exactly where it's located. You see, it's in row number 1 of my answer matrix, and it's in column number 1 of my answer matrix. So your R1, C1, your row 1, column 1 is going to equal, you actually multiply together row 1 of the first matrix times column 1 of the second matrix. So the first element is 2. That gets multiplied by -1. And then there's a plus in between. There's always a plus. And then you move to the next element in the row and column. So that would be 1 multiplied by 3. Now, that is what you actually do. But there's always a multiplication and an addition involved. 2 times -1 is -2. 1 times 3 is 3. You add those together, you get 1, which tells me, ladies and gentlemen, that the number that goes here in row 1, column 1 is 1. There. That's one number. Now you have to come up with 11 more. If you want to get this element next, notice that's in row 1, column 2. So you would write R1C2 is equal to. And now what you would multiply together, let me just get my eraser for a second. Now what you would multiply together, because you're after row 1, column 2, well, there's row 1 again. And now here's column 2. So 2 multiplied by 6 plus 1 multiplied by 0 would give you this number there. So you have 2 times 6. Sometimes you might better use brackets. 2 multiplies by 6 plus, and then you have 1 multiplies by 0. I think that's a 12. So 12 goes right there. Now, let's keep it up. The next thing you want to find is this number, which is in row 1, column 3. So again, you multiply row 1, but this time, not column 2, you're actually going to be using column number 3. So R1C3 is going to be 2 times 5, that's 10. And 1 times 1 is 1, and that is 11. So that's how you multiply matrices. Now, after you try this for a while, after you practice it a bit, you get really, really quick at it. It becomes very, very fast. If, that is, you are going to do it by hand. It's not really necessary to multiply them by hand. It's a good idea to know how to do it, but for the most part, you won't be multiplying them by hand. You'll just be able to use your calculator. But like I say, after a while, you do get really fast. So the number that goes right here now, for example, would be 2 times -2, which is -4. And then 1 times -4 is another -4. You add those together and you get -8. You could fill these out fairly quickly if you wanted to. There's another one there that you can try. Try setting up your calculators to see if you can multiply matrices with your calculator. Now, please note there's an appendix in the back of this textbook that you can refer to on multiplying matrices. I'll see if I can get a video set up. I know I have an emulator for the Casio calculator, but I can't seem to locate it here now. Look up on YouTube, everyone. Find a video on YouTube. If you just typed in how to multiply matrices on a Casio and then give your model number, I'm sure there's probably dozens of videos on how to do that on YouTube. Okay. Now, another thing I'd like to point out that's important. If you come back here and look at the matrices we just multiplied, look at these two right here. I'm just going to erase all of this stuff because there's something in particular I want to show you. It's kind of weird, but it's very, very, very true. All right, now here's what the weird thing is. Let me write down the dimensions of those matrices again in under. Remember, matrix A it had 3 rows and 2 columns, so that was a 3 by 2, right? Matrix B had 2 rows and 4 columns, so that was 2 by 4. So the question that we asked was, are we allowed to multiply them together? And the answer was yes, because the 2's in the middle are the same. And remember then that our product matrix, our answer, is going to be another matrix with dimensions 3 by 4, which is given right there. Watch what happens if you try to switch around those two matrices. What if instead of saying A times B, A multiplied by B, like that, in that order, what if you tried to multiply B times A? In other words, what if you just switch them around? What happens? Well, the size of B, remember, we just said a moment ago, was 2 by 4. Wasn't it? The size of A, we said a moment ago, well, it has 3 rows and 2 columns, so that's a 3 by 2. Now, look what happens. Just by switching them around, now the numbers in the center are not the same. In other words, you're not allowed to multiply b times a. If you tried it on your calculator in that order, you would get an error. So in general, everyone, if you look at the bottom here on page 6, in general, matrix multiplication is not commutative. Now, we've already seen that it's commutative under addition, but it's not, in general, commutative under multiplication. So in other words, a multiplied by b, assuming you can do that, is not going to give you the same result usually as b multiplied by a. In fact, sometimes you can't even do the multiplication if you switch the order, as we just saw in the previous example. Now, one other thing I'd like to get over today, talk about with you, is something called the identity matrix, which we referred to. The identity matrix now is a square matrix. It can be 2 by 2 like this one, 3 by 3, 4 by 4. It can be any size, really, as long as it's a square matrix. And we said that the identity matrix, it acts like the number 1 in integers or in the real numbers. It acts like the number 1. If you take any real number and multiply it by 1, of course you get back the real number that you started with. And that's why 1 is called the multiplicative identity with regards to the real numbers. Now, let's see what happens if you take a matrix like A, 7, 1, 3, 2. Now notice it's a square matrix, 2 by 2. Right, that's 2 by 2. If you were to multiply that by the identity matrix, which is 1, 0, 0, 1, let's see what happens. Notice it's also 2 by 2, so are we allowed to multiply them? Yes, there's 2 in the centers are the same. And the answer, your product matrix, is going to be another 2 by 2. 2, 2, 2. Okay, there you go. There's your answer. Let's go ahead and multiply them now. Row 1, column 2 is 7 times 1 plus 1 times 0. That's a 7. Row 1 times column 2 is 7 times 0 plus 1 times 1. That's a 1. Row 2 times column 1 is 3 times 1 plus 2 times 0, and that's a 3. And row 2 times column 2 is 3 times 0, 2 times 1, that is a 2. Now, let me just show you what happened here. Watch what happened. I'll just erase all the fluff that's around them. And look what happened. 7, 1, 3, 2 was your original matrix. You multiplied it by the identity, and voila, you got back the original matrix that you started with. Now, that's not surprising. In fact, that's why this matrix here, that's why it's called the identity, because it's like a multiplicative identity. And even if you switched around the order, the same thing would happen. A times I is equal to I times A, which is equal to A. All right, so you might ask yourself, oh, that's not really all that interesting. Well, but it has implications when we start to solve matrix equations in just a little while. All right. So anyway, I'll stop there for this lesson. And when we come back to our next lesson, I'll go over very quickly something called the inverse of a matrix. And then we're going to dive right into solving matrix equations. So I'll stop there for today. Anything for practice? Not really. You could try to multiply these two here. Try the practice example as well there on page 6, and try to use your calculators to multiply matrices. It's not difficult. It's not difficult, but you can easily find videos of that on YouTube. Okay, so until next day, bye-bye for now.